Okay, let's pick back up here without all of the repetition. So let's do another one here. Let's say I want to solve 2x minus 3y equal 5 and x plus 2y equal negative 3. So the augmented matrix would be 2, negative 3, 5 for the first row, 1, 2, negative 3 for the second row. Now since I want a 1 right here, I can swap row 2 with row 1, and that would give me a 1 there where I want it. So let's do that. Let's swap the two rows. So now I have a 1 here. So row 1 is now up here, 1, 2, negative 3, and row 2 is on the bottom, 2, negative 3, 5. Now, once I get that 1, what do I do to get rid of this 2? Well, I need to multiply this row by negative 2 and add it to row 2. Now remember, I'm not changing row 1, I'm just going to change row 2. And then I'm going to put the result in row 2. Now let me write down the numbers for you that we would get. So if I multiply row 1 by negative 2, they would change, those numbers would change to these numbers. Negative 2 times 1 is negative 2, negative 2 times 2 is negative 4, and negative 3 times negative 2 is 6. And then I add these to row 2. So negative 2 plus 2 gives me a 0 right here. And then negative 4 plus negative 3 gives me negative 7 right here. And then 6 plus 5 gives me 11 right here. So then I have this negative 7 in row 2. Once I've got this column the way I want it, now I can go down to the next row, and I want to make this a 1. So I'm going to multiply this row by the reciprocal of negative 7, which would be negative 1/7. Well, we're going to have some fractions in some of these problems, and that's what's going to happen here. But negative 1/7 times 0 yields a 0. Negative 1/7 times negative 7 is positive 1. And negative 1/7 times 11 is negative 11/7. Now, I want to use this 1 to eliminate this 2 that's above it. So what I need to do is I need to multiply this row 2 by negative 2, so that when I add it to row 1, it'll cancel the positive 2. So when you multiply row 2 by negative 2, you're going to get 0, negative 2 times 1 is negative 2, and negative 2 times negative 11 is positive 22/7. So now I'm going to add that to row 1 and put the result in row 1. 0 plus 1 is a 1, so I'll get a 1 here. Negative 2 plus 2 is 0, so I'll get a 0 here. And then 22/7 plus negative 3. Well, notice up here I wrote negative 3 as a fraction for you as sevenths. Negative 3 is equivalent to negative 21/7, and so 22/7 plus negative 21/7 gives me 1/7 for the answer. So now I know x is 1/7 and y is negative 1/7, and so that's my solution to that system of equations. Now I realize that when you solve these smaller systems like this, it may seem like a lot of work to use matrices. But remember, the matrix method is for larger systems, but we have to start with smaller systems so that we don't overwhelm you. Okay, here's another system with two variables and two equations, and I used x1 and x2 instead of x and y this time, but it doesn't affect the way you put it in the matrix form. The coefficient is 2, negative 1, and negative 6 and 3, and the constants are 4, negative 12. So this would be the augmented matrix. Now, I want this to be a 1, so since I don't have a 1 that I can trade out with the bottom row, I'm just going to multiply this row by a half. So a half times 2 is 1, a half times negative 1 is negative a half, and a half times 4 is 2. Now, I want to eliminate the negative 6, so I'm going to multiply this 1 by 6 and add it to this row to cancel the negative 6. But if I do that, then 6 times 1 is 6, 6 times negative a half is negative 3, and 6 times 2 is 12. And if I add those three numbers, 6 plus negative 6 is 0, negative 3 plus 3 is 0, and 12 plus negative 12 is 0. So it seems like it canceled my entire row here. Well, what that tells me is if I take this now out of the matrix and write it as an equation, this would be x minus 1/2 y equals 2, or in our case, x1 minus 1/2 x2 equals 2. And the second row just says 0 equals 0, which doesn't contradict anything. So then I can take this and I can solve for x1 in terms of x2. So x1, by moving the minus 1/2 x2 across the equal sign, is equal to 1/2 x2 plus 2. So now I can write the solution set by saying, well, x2 is just going to equal x2, and then whatever x2 is, x1 is going to be 1/2 of that value plus 2. So I would have 1/2 x2 plus 2 for the x value, and then x2 for the y value. And again, you could use, if you don't like x2, you could just pick a letter like k and put k there instead of x2. But because all you're doing is describing how those two variables are related. Okay, now if I took a similar problem and did the same thing, like for instance on this problem, the augmented matrix would be 2, 6, -3, 1, 3, 2. And then if I can swap the rows, so I get a 1 up here, and if I multiply this by -2, that would give me -2, -6, -4. And then if I add those to the second row, -2 plus 2 is 0, -6 plus 6 is 0, and -4 plus -3 is -7. Well, in that case, then I would have, this row would say 0 equals -7, which is an impossible equation. So when we get an impossible equation, we know we have no solution, so we have an inconsistent system. I'm just going to summarize this here, and you can pause the video if you want to look through it, but I just wanted to do this to show you the relationship between solving a system with and without matrices. The way we would normally solve this without matrices is we would find two equations that we could add together that would eliminate a variable, and then we would try to find another two equations that we could manipulate in a way to eliminate the same variable, and then we've basically reduced it to two equations and two unknowns. And then so we would take those two equations and try to eliminate a variable. So here, if I add these together, I eliminate the y, and then I get 2x equals 4, or x equal 2. Well, then I can start back substituting. I can take this 2 and plug it back into this equation to get y, and so now I have x equal 2 and y equal 1, and then I can go back to one of the original equations and plug in the x equal 2, y equal 1, and solve for z. So I go to this equation and plug in y equal 1, x equal 2, and solve for z. Well, some of the stuff I did here is actually kind of what's going on when we solve in a system with augmented matrices. So let me show you that same problem using augmented matrices. Okay, so you're pretty familiar now with how to put the system in an augmented matrix, so we'll start there. Now, this is a larger system and it has 3 variables and 3 equations, so we want our augmented matrix to look like this. Now, I said if possible because it's only going to look like that if we get a unique solution. So let's see how we're going to go about it. So the first thing we're going to want is we're going to want a 1 here. Well, the good news is we already have a 1 here, so that's taken care of. Now I need to get rid of this 2. So to get rid of the 2 that's under it, I can multiply this row by -2 and add it to row 2 to cancel it. And then I need to get rid of the 1 that's down here, which I can do by multiplying this row by -1 and adding it to this row. If I multiply row 1 by -2, these are the values that I would get, and I'm going to add them to row 2. So -2 plus 2 is 0. -4 plus -1 would be -5, and then 2 plus 1 would be 3. And then finally -2 plus 6 would be 4. And then if I multiply this row by -1, I would get these values, and then add those to row 3 to cancel the 1. So -1 plus 1 would give me 0, -2 plus 3 would give me 1, 1 plus -2 would give me -1, and then -1 plus -1 would give me -2. And so that would give me that row. Well, Well, then what I want to do is I'll go down to the second row, and I want this element to be a 1. Since I have a 1 below it, I can just swap these two rows, and that's pretty simple to do. So let's just say we swap row 2 with row 3, and now we'll get a 1 right here. Now after that, I need to eliminate the 2 that's above it, so I'll multiply -2 times row 2 and add it to row 1, and I'll also multiply row 2 by 5 and add it to row 3 to cancel the -5. So that would be this row operation. And let's see how that works. Okay, so this is what I would get if I multiply row 2 by -2. Then I would add those to row 1. So 0 plus 1 is 1, -2 plus 2 is 0, 2 plus -1 is 1, and 4 plus 1 is 5. Then if I multiply everything in row 2 by 5, I would get these values, and I would add those values to row 3. 0 plus 0 would give me 0, 5 plus -5 would give me 0, -5 plus 3 would give me -2, and -10 plus 4 would give me -6. And so now I need to go down here and make this a 1. Now there's no row to swap with to get a 1, because you might think you could swap with this one up here, but if you do that, that's going to mess up some of the stuff we did in the previous steps. So we only want to swap with a row that's below when we do that. So now what I have to do here is I have to multiply this by the reciprocal of -2, which is -1/2. Now when you multiply the zeros, they're just going to stay 0, and then -2 times -1/2 is 1, and -6 times -1/2 is 3. And then I can take negative row 3 and add it to row 1 to cancel the 1, and then just take row 3 plus row 2 to cancel the -1. Now this is not that difficult, so I think we can just do this. If I multiply everything by -1, it's just going to change the signs, and then I'm going to add it to row 1, so the zeros won't change. So 0 plus 1 will be 1, 0 plus 0 is still 0, and then changing that to -1 plus 1 would give me 0, and then changing this to -3 plus 5 would give me 2. And this next step's even easier. Row 3 plus row 2, just add them together. 0 plus 0 gives me 0 here, 0 plus 1 gives me 1 here, 1 plus -1 gives me 0, and then 3 plus -2 gives me 1. And now I can see that x is 1, x is 2, y is 1, and z is 3. And that's your solution, the order triple 2, 1, 3. Let me wrap this up by just summarizing another example, and then on the next video I'll do some application problems for you for this. Okay, so here we have a system of 3 equations and 3 variables, and you know how to put it in matrix form by now. So let's just say we put it in a matrix form, and then we start working with it. So I'm just going to summarize these steps here. So I need a 1 here, so what I'm going to do is I'm just going to swap row 3 with row 1, and that'll get me a 1 there. Now I want to eliminate the 3, so I'm going to multiply everything in row 1 by -3 and add it to row 2, and that'll give me a new row 2. Now you can do the arithmetic yourself. Just multiply everything here by -3 and then add it to their corresponding pairs in row 2. And you should get 0, 10, -7, 7. And then multiply everything by -2 and add it to row 3, and you should get 0, 4, -3, 3. Then to get a 1, I'm going to multiply everything in this row by -1/10, and that's going to give me this row. Then I'm going to multiply this by 3 and add it to this row to cancel this, and multiply it by -4 and add it to this row to cancel this. And then I'm going to have a -1/5 in row 3, so I'm going to multiply that by the reciprocal, which is -5, and that's going to give me a 1 here. And then I'm going to multiply that 1 by -1/10 and add it to row 1 to cancel the -1/10, and then multiply it by 7/10 and add it to row 2 to cancel the 7/10. And then I would get this, which tells me that x is 2, y is 0, and z is -1.